Grade 10s, now we're going to be talking about probability. Remember, we're in the section on data handling, and we're going to look at probability of events. We're just going to do a video on terminology. We're going to delve into a lot of recapping of what you did in previous grades, and then we're going to touch on a new section all about unions and Venn diagrams, and we're going to get into that right away. And that's where we're going to get into Venn diagrams, probabilities of different mutually exclusive or inclusive events. So we're going to fill something in this block here afterwards. Right, let's recap grade 9 quickly. Probability is a measure of how likely something is to happen, right? How likely something will happen. For example, what is the probability of me flipping a coin, right, and it landing on a heads? I flip a coin into there, what is the probability of it landing on a heads? Right, what is the likelihood it will land on a heads? You can quite imagine it will either be heads or tails. They each have 50% chance of landing on heads. So the probability or likelihood of this happening is 50%. Right? That makes sense. Now don't forget that 50% is the same as 0.5 and 1/2. That is all the same as 50%. Okay, let's have a look at some more terminology. An experiment is an action with an uncertain result. If you jump and you want to measure how far you can jump, you don't know how far you're going to jump. It's an experiment. If you throw a dice into the air, you don't know what number it's going to land on. You're experimenting. If in science you do an experiment, you don't know what's going to happen. An experiment is an action with an uncertain result, right? So we don't know what the result is going to be. We know there's a couple of possible outcomes. For example, the dice could be a 1, 2, 3, 4, 5, or 6, but it's uncertain which one of those it'll be. A sample point is a single outcome. For example, we throw a dice. The sample point is just one of those outcomes, a 1, a 3, a 5. A sample space is the set of all possible outcomes, right? We denote this by the symbol S. We use S to say sample space, and the total number of outcomes is NS. So the sample space S is in a dice, it's either 1, 2, 3, 4, 5, or 6, and there are 6 options. So the number of the sample space, that would equal, in the dice's case, 6. We'll get more into that now. An event is a single set of results for an experiment. This is shown by the symbol E. The number of outcomes in an event is shown by the number E, or NE, sorry. Okay, so let's have a look at an example. How many times will I throw a double? You might remember this from previous years, when throwing 2 dice. Each time I throw it, it's an experiment because the result is uncertain. So what does it sound like? An experiment. The result is called an event E. The number of E is 6 because there are 6 possible ways to get a double. So what are the possible ways to get a double? So that's an event. There's 6 possible ways to get a double. So the number of, ignore this, sorry, this was an old with where we weren't trying to get a double. So the number of possible events that we want, a single set of desired results, is number E, NE, and that is 6. There are 6 desired events outcomes, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. That's the only way you can get a double. There's 6 of them. Those are called our sample points. It's a single outcome that we want, and there's 6 of them. There are 36 possible outcomes, right? So the number, NS, of the possible outcomes, the sample space, is 36. We could roll a 1 and a 1, we could roll a 1 and a 2, a 1 and a 3, a 1 and a 4, all the way to a 2 and a 1, a 2 and a 2, 3 and a 3, 3 and a 4, 5, 6 and a 4, 6 and a 5, all the way to 6 and 6. And this is our sample space. This is denoted by S. There are 36 possible unique combinations we could get. Right, so let's have a look at another example. What is the probability of a dice landing on a 3? The next 2 examples I'm going to show you very quickly. So the sample space would be 1, 2, 3, 4, 5, 6. This shows that the total number of outcomes, NS, is equal to 6. We want the dice to land on a 3. So the only event we want can be represented by N. The event we want is 1. There's only one outcome, and that's 3. Right? So the probability or likelihood of this happening is 1 over 6. There's 1/6 chance that a dice will land on a 3 when you throw it. And that is 16.67%. Let's just have a look at another example, very similar. What is the probability of a dice landing on a 3 or a 6? You're going to see where this all comes into play soon. So we could have two possible outcomes here. So the sample space again would be 1, 2, 3, 4, 5, 6. It could land on any one of those. So again, NS is equal to 6, the number of samples. So we want the dice to land on 3 or 6. So the event we want can be represented by NE equals 2, because there's two possible events that we want. Those are both desired. So what is the probability or likelihood, they both mean the same thing in this case, of this happening? Now that will be 2 over 6. That is the NE over NS. Do you see that? So the number of desired, or the number of events, desired events, over the number of the sample possible events. And that is 2 over 6. And that is 33.33%. Okay, now I want to just go over this section. If something happens in A or B, we call it a union. I've highlighted this U here. Right, A or B, we call it a union. This is the same as writing A, and then we do this little upside down sort of curve, or it looks like a U. It looks like a capital U without the line going down the side. So we write that A union B, and the easy way to remember this is the U for union. So just remember that U is union, that easy. Okay. I just want to show you this. This is all I want you to learn in this part of this video. If something happens in A and B, we call it an intersection, right? And in intersection, there's an N here, and this is the same as writing A, and now that's an upside down one of these, U, A, upside down U without the doiki, or without the line, B, and that is N for intersection here. I've tried to put that N over there. Okay. If something happens in A, but not B, or alternatively B but not A, we call it mutually exclusive events. They're exclusive to each other. They don't have anything to do with the other one. And that is the same as writing A and B equals 0 with a strike through it. So you can practice writing 0 with a strike through it. Neither those two. Okay, from here we're going to get onto Venn diagrams. And that looks like something like this. So here you can see is where A and B interact, for example, but we're going to get into that in the next video. What we're putting in terminology here is the probability is a measure of how likely something is to occur. It is calculated using a sample space S and event E. Let's move on. Now we're going to do relative frequency.